Hey guys, as I'm editing this video here, I just wanted to give a little intro and a little context to what we're dealing with at this pool. So before we go into that, I just want to talk about chemistry for a couple of seconds. Whenever you're doing pool chemistry, if you look online, you're going to find ranges where your chemicals should be at. For example, chlorine should be 3 to 5, pH should be 7.4 to 7.6, and so on and so on. You can look up ranges for all chemicals. The thing is, in pools, you're not always going to be within range in all your chemicals. So when that happens, you have to be able to adjust to those things that you can't control. In this example here in the video, what we're going to find is that we had a high conditioner level or high cyanuric acid level, and our alkalinity seemed okay, but yet our pH was low. Throughout the video, I explain exactly what's happening, how the conditioner is affecting our alkalinity, and how in the end that all boils down to why we have a low pH.
Chemistry here, chlorine is very high and pH is very low. So we're going to check alkalinity and make sure that's where it needs to be. For alkalinity, our water needs to be at 25. Easy way to do that is to drop your water until it drops down to about this black part and then turn it back up and you're right there. 10, and at a 10 it changed completely. So we're between 90 and 100. So that's where it should be. So why is our pH so low then? I have a feeling we may be using too many tabs, but let's check the conditioner first and we'll see. Conditioner super high, we know that we've probably used too many tabs here, and then I'll check the floater over there. Our conditioner here, by the way, is showing at a whopping super high reading. So now let's just check our tabs, see how many are in here. This has 2 tabs, so it's not being overdone. All right, so we still have an issue though. We've got low pH and alkalinity is where it needs to be. So part of that problem too could be caused from a high conditioner level. And the way I'll explain it is that if your CYA is 100, you take a third of that, which would be 33. You subtract 33 from your alkalinity, and what that gives you is your total adjusted alkalinity, which is actually your true alkalinity reading.
All right, let's write this down on paper so we can all make sure we grasp this. In our pool, we had a cyanuric acid level that was quite high. I don't know exactly what it was. It could have been 300, could have been 250. We're just going to use the number 250 here for our CYA. Now, to find our total adjusted alkalinity, we have to first divide 3 from our CYA. Why did I write down 100 here? Because that's the reading we got on our Taylor kit at the pool, which, you know, if we go by range chemistry, that would say that our alkalinity is actually fine. It's actually right between 80 and 120. So we would say, hey, our alkalinity is perfect. So, you know, we're good to go. Let's go on to the next pool. But let's find out in reality what this means. Our CYA, once again, is 250. So if we divide by 3, this is going to give us a number of 250 divided by 3. It's going to give us a number of 83. Okay, so now we can take our alkalinity here and subtract 83 from it. And if we take 100 then, our alkalinity, and subtract the 83 from it, we get a 17 for our adjusted alkalinity. So now looking at this, you can understand and see why our pH is so low. We were going off this number here, which would normally look okay, but with our CYA being this high, we see that the true alkalinity here is 17, and that's why our pH is where it's at. So how do we fix this? The right thing to do would be to tell the customer, hey, we need to drain the pool. but not everyone is open to that. Or in California, sometimes we have droughts and we're not allowed to drain pools and add that much water into a pool. So how do we fix this? How do we combat what we're dealing with at this pool? Because at this alkalinity, what's going to happen is that you're going to make a heat exchanger go bad in a pool. You're going to start etching a pool. The water is considered corrosive, it's considered aggressive, and you don't want to leave a pool like that. So the way we fix this is, we fix the alkalinity. Based on this number that we know here, for the CYA, we can make adjustments so that our alkalinity falls within what would be a good range, so that we're not damaging equipment, so that we're not damaging the pool. So if our adjusted alkalinity is 17, well, let's go ahead and add sodium bicarb to bring that adjusted alkalinity up. So I would add enough bicarb to the point where my alkalinity is now testing maybe 180. Oh, what a bright, horrible. 180 to 200 in my alkalinity on my Taylor kit, so that when we do adjust for that CYA, when we subtract the 83, let's pretend also from 200 here, we subtract 83 from 200 or 180, we're left at this point with a 97 here on adjusted alkalinity, which is right, AA, adjusted alkalinity. Or if we've got 200, we're left with an adjusted alkalinity of 117. And when we're at 117 or 97, you should see your pH level start to become what you normally see at pools, which is 7.8. Sometimes you come to a pool and if you're lucky it might be a 7.6, but usually it's on the higher end. But you should see that change as soon as you bring your alkalinity via your Taylor test kit to 180 and 200, because when you account for that CYA, which CYA, if you just by the name of it, it's an acid. That's why it affects your pH. It should be able to be balanced. That pool should be able to be balanced until you can talk to the customer. You can get permission from the city or the water department to actually drain the pool and refill it with fresh water. So that's it. Hopefully that makes sense.